Right, so here my suggestion is to always try direct substitution, but when we plug a 2 into the denominator, 0. Okay, well then when we look at this, there's nothing to factor here. There's like no difference of squares, no trinomial. But what makes this unique is it's got a complex fraction, so fractions within a fraction. So when we see something that looks like this, you're going to look at the part with the many fractions and you're going to figure out what the common denominator is. So a lot of times that's just like joining your denominators. So our common denominator is going to be 2x. So we're going to end up multiplying the top by 2x. But to make it balanced, I have to multiply the bottom by 2x as well. And then we're going to distribute that 2x through. So 2x times 1 over x. Think about what that does. 2x times 1 over x. What does that simplify to? 2. Okay. Then minus, what's 2x times 1/2? X, yeah. So there, by just multiplying by its common denominator, the whole top simplifies to just 2 minus x. Then on the bottom, I am not going to distribute that through. I'm just going to leave it x minus 2 times 2x. Okay, now remember our goal when we were factoring was to see if there was a hole or something like on the top and the bottom. Is there an exact match on the top and the bottom? But could we manipulate it in some way that there was a match? Do you remember what you could do? If I factor a -1 out of the top, that becomes -2 plus x, which is the same as this. Then do we have something we can cancel? Yeah, we can cancel the x minus 2's, and we get -1 over 2x. And now that we got rid of that we canceled something out, now we're going to try direct substitution. And if we plug in a 2 in for x, we get this. That's our limit. So the ending is kind of the same. You're looking for something to cancel and then doing direct substitution. But this part is different now. We're multiplying by common denominators. Okay, let's try another one. Let's do, it'll be oh man. One time.
like never ever get back to that, or just have to end up going in it.
Yeah, I would just stop it.
Speech class, like I keep showing up to class, I'm like, this matters. I'm trying to get out of here.
All right, so here, if we put a -3 in the bottom, it would be -1/3 plus 1/3, 0. But we've got a complex part, but now it's in the bottom, and that's okay. So for those mini fractions, what would be our common denominator? 3x. So we're going to multiply the top and the bottom by 3x. I'm not going to mess with the top at all. I'm not messing with the part that doesn't have the mini fractions. So I'm just going to copy over x plus 3 times 3x. For the bottom, I'm distributing that through. What's 1 over x times 3x? Plus, what's 1/3 times 3x? Is there something that cancels out? Yeah, because they're both positive. That's the same thing. So then we have 3x. Now try direct substitution. There's my limit. Okay, let's do another one. I'm going to up it up just a little bit. I made this one up. It doesn't have a number. I made it up. Okay, we're going to do the limit as x approaches 0 of 1 over 3 plus x minus 1 over 3 all over x. So plugging a 0 in, no bueno. Common denominator. What do we think our common denominator is for the top part of that? That's better because we're still multiplying them together. But I'm also going to, like you already distributed in your head, I'm not going to distribute it. And I'll tell you why here in a second. But yeah, you just take your 2 and multiply them together, top and bottom then. Here's why I'm not going to distribute, why we're not going to distribute. When I do this part right here, that first arrow, it's 1 over 3 plus x times 3 plus x. See how it's easier to think about how they cancel? So then there's just a 3 left. Minus, what's 1/3 times all of that? So it's like 1/3 times 3 plus x. Just these 3's cancel. 3 plus x. Now, we're subtracting that, so we need to put parentheses because we're subtracting that whole binomial. That's kind of messier, I know. So are we okay with that mess? Okay, now on the bottom, I'm still not going to distribute anything because it's harder for things to cancel. So on the bottom, I'm just going to kind of write that all together. X times 3 plus x. Now for that numerator, think back to algebra 1. In algebra 1, you would have distributed the negative, and it would be 3 minus x. So that's kind of distributing that negative, getting rid of the parentheses. What's 3 minus 3? Nothing, right? Okay, great question. So we can only cancel when it's complete multiplication. So because there's a minus sign there, it's stuck. Yeah, good question. On the top of this, though, now that 3 minus 3 is 0, we just get a negative x. Is there something we can cancel? Right, and so then technically what we can just do then is leave that as a negative 1 on the top, cancel those x's out, get 3 times 3 plus x. Hi, Ella. You're going to take one of my 3? Cancel, then we can plug our number in for x. So then it's going to be negative 1/9 is our limit. So it just takes a little bit of practice, but it's just a bunch of algebra when you get down to it. Okay, I've got one other method to show you. We'll see what you remember from this. It's a different method than common denominators. I'm going to start with 26, and then you can teach Kylie. Yes. Here we go. Hey, Ava. I mean, as always, we would try direct substitution. Still doesn't work. We can't factor this. There isn't a complex fraction, but there's that square root. Do you remember something from algebra called conjugates? So a conjugate is where you take the part with the square root, you copy it over, but you change the sign in between it. So we're going to multiply by square root of x plus 4. So conjugate, you keep it, but change the sign. But if I multiply the top by that, or the bottom by that, I also have to multiply the top by that. I got to balance it out. So this is the conjugate method. Now, that top part, I'm not going to mess with it. I'm just going to copy it over. So I'm going to make it x minus 16 times the square root of x plus 4. Now, I don't know what algebra you would have had this, but do you remember what the purpose of conjugates was? It does. And what it ends up doing, like when we FOIL it, the outsides and insides cancel. So really, we just have to FLA this. Multiply the first together and the last together. So if we multiply the first, what's square root of x times square root of x? And if we multiply the last, what's negative 4 times 4? Do we see something we can cancel out? No, that's our whole purpose. Once we get those canceled out, then we have the square root of x plus 4. Now we can do direct substitution and get 8. So ultimately, all of these things, you're getting where you cancel out in there. It's just how we get there it changes. Okay, let's try another one of these. Okay, so plugging in a 0 into the bottom, no good. We can't factor this, we can't do common denominators, but the top has a square root. So we're going to multiply by this conjugate. Only change this sign though. Don't change any signs underneath the radical. And we're going to multiply by that on the top and the bottom. Okay, so the top is the part with the conjugates, so that we're going to FLA. So the first, what's 4 times 4? Yeah, minus what's going to be left with those radicals is a 16 plus x, but we've got to put that in parentheses. And then on the bottom, I'm not going to mess with that. I'm just going to do x times that conjugate. Okay, I'm going to see if we can skip a step. If we're not comfortable with it yet, that's fine. But what's the numerator simplified when we distribute that negative through? Negative x, because it'll be 16 minus x. So then it'll be a negative x. And then we have this on the bottom. And then do we see something that cancels? The x's cancel. So we'll have negative 1 over 4 plus the square root of 16 plus x. After you cancel, the next thing we do is direct substitution. So now we're going to plug a 0 in for x. And that'll be negative 1/8. And there's our limit. So now we know it all. We just have to practice. So there's a lot of factoring, common denominators, and conjugates. So the real schedule for the week is this. I've got a worksheet to start today. Tomorrow we're going to keep working on the worksheet. Wednesday we're taking pictures. Thursday we're going to review it all. And Friday we're going to have a quiz on 1-2 and 1-3. So that's what our week looks like. So nothing new now. Now we just perfect it till our quiz on Friday. Okay, so let me pass out this worksheet. That's going to take us